In a universe shrouded in mystery, where the stars are our only companions, a journey awaits that will push the boundaries of knowledge. Prepare yourself for something that will redefine our understanding of technology, unveil the secrets of the cosmos, and witness the marriage of human ingenuity and artificial intelligence. We bring you the flagship event of IEEE SISGST, the Galaxy of Intelligence, Epsilon. A triad of scholarly symposium days guided by the wisdom of global pioneers and visionary minds. An event designed for everyone to gain knowledge and cultivate interest and curiosity. In this edition, we give you Narrow AI. Narrow AI is the concept of brainstorming events that have a significant impact on AI technology, with humans like us, you, and me. We're not different, we are the same, with faraway souls. The concept of AI extends from the tip of your hair to the last cell of your nail. Computer vision. Computer vision excels in a field where robots outperform human vision. We will construct a future, the light of invention, together. Self-traveling dreams during the day and night. Algorithms flare in this world of pixels, revealing faces and emotions in the darkest night. With each step forward, we go closer to the future, the promise of computer vision and an unending flight. Deep space communication. MTT assistance passing across galaxies in its path. Deep space learning is a place where mysteries wait. As boundaries disintegrate, the cosmos is revealed. The brilliance of AI and technology, the resolution of a cosmos. We gather at Epsilon, braze eager and bright, in the light of AI to comprehend the cosmos. Prepare for an intellectual adventure like no other. Mark your calendars because the future awaits. Epsilon 2023 starts 30th September, live on YouTube. Brought to you by IEEE SISGST.
So, good afternoon, everyone. Hello and welcome to the third session of the Day 3 Epsilon 2023. I am Sanket Patil, Administration Head at IEEE SISGST.
And I am Kunal Jense, MDO at IEEE SIGST. We hope that everyone who participated in Epsilon 2023 had a wonderful time. Also, we are thrilled to have everyone join us. The journey is far from over. Over a third and last session on the MTTS track, an outlook on space future will feature a panel discussion with some outstanding speakers from around the world.
I would now like to introduce you to all our panelists of the day. First, we have our moderator, T.S. Uma Shangri Aruldas, a Malaysian aerospace enthusiast, holds a professional technologist degree in aerospace and aviation technology from Malaysia Board of Technology. As Bergia Airline Technical Services and Planning Manager, she achieved numerous honors, including presenting research at the ICAO's Global Aviation Gender Summit 2023. She is a speaker at TEDx, and she is being recognized globally for her work in space debris management innovation. Welcome, ma'am.
Next, we have Dr. Mitra, a co-founder and academic head of STEM and Space in India, holds a PhD in astronomy from Rice University. With a NASA background and involvement in Nobel Prize-winning Cosmic Background Explorer project, she champions STEM education through space-related initiatives. She conducts workshops, coordinates the astronaut search campaign, and serves as a spokesperson. She also she also represents the India at an international conference by actively mentoring students and amateur astronomers. Welcome, Dr. Mitra.
Thank you.
Next, we have Ms. Rung Vilasin, is a dedicated advocate for inclusion and equity in space sciences. Collaborating with IAU SWG, Inclusion and Equity, her studies at International Training Center of Astronomy, Bangkok, and Space for STEM Education in Vietnam highlights her commitment to space education. Partnering with MIT on a sonification devices showcases her blend of science and art. Welcome, Ms. Rung, to this amazing and informative panel discussion.
Next, we have Mr. Anuj Soni. He is a project assistant at OU Hyderabad. He specializes in aerial and satellite imagery, utilize GIS tools to interpret geographical and geological data. His research focuses on planetary studies, specifically mineralogy and abundant analysis. The connection between tectonism and volcanism and origin of the earth on the earth and distinction between the Mars quake and earthquakes. Welcome to Mr. Anuj Soni. We are welcome, sir, to the amazing panel discussion.
Next, we have Ms. Maithili Deshpande. She is a researcher at Deep Space Initiative's Astro Summer Intern 2023 and Research Intern at SSERD. We welcome you, ma'am, for joining us with the amazing panel discussion.
We are truly grateful to have all valuable speakers in our panel. So now I would like to hand over my mic to moderator T.S. Uma Shangre ma'am.
Thank you so much to our dear host. It is indeed overwhelming to share the virtual stage with the experts worldwide. It's indeed an honor. Thank you for having me. If you could see, all of us over here are experts, subject matters, and we have some achievements done here and there. But always remember that before we get to the stage where we are today, once we were a child as well, once we were a teenager, once we were a student as well. So, before we get started and delve into the technological part and also the extra statements from the reality that we are going to witness in short while, perhaps we can take this time to have a minute or two with each and every panelist of us, asking what has been the inspiration behind their space journey. In order to get started, perhaps I would love to invite Mr. Anuj. Mr. Anuj, would you love to share the inspiration behind who Mr. Anuj is today?
Thank you so much, Ma, for inviting me on the stage. And definitely, It has been a very great journey from where I actually started. Um, I remember at the one night, or you can say at a one evening, I was actually looking at the sky and one, what we called it as a shooting star coming down, falling down, right? And I was very curious about it, like why it is coming all the way from there to here. So I started actually chasing it. I started using my
Oh,
cameras to chase it where exactly it is going to fall it, right? And ultimately, when I reached there and I found nothing is there, right? So at that day, it made me very curious, and I went to my home and asked my father and mother, like how a star can fall on the ground and what how they are made up of and where exactly they went because I went there and there is nothing, right? So that thing, that question arise at my mind, like how these things are actually happening. And I remember when I was in my 10th or 11th grade, there was one chapter about the dinosaur extinctions, right? So how exactly they extinct. So that also made me a very curious about this particular subject, and then I got to know that that particular asteroid that falling that day was the reason for their extinction, right? So there how that's how I link my journey there, right? So I investigate all these things and I pursue my career in the geology where I actually studied about the dinosaur, about the asteroids, about the Earth formation, as well as the formation of a universe, right? And like the very curious question that comes at that point, like after the extinction of dinosaurs, that giant creatures, how humans arrived, right? So that is the biggest question. So that also leads me to, take a path journey and you can say, I actually unravel the questions and try to figure out how exactly things happen and how the life originated on Earth and what we can expect in different kind of planets and different kind of exoplanets, you can say, right? So this comes lead into the astrobiology branch where I'm currently right now doing my work. And for that, at the same time, I was very much curious about the different type of planetary bodies such as Mars and Moon, and how we can study it because it's very much expensive and we can't expect to go there right now, right? So there is a technique called remote sensing that we can right now using, capturing the images, and by that we are creating the past history of that particular planet. So that's how my whole journey began, and that's how I'm going in that track, you can say. So that's all about my dream and how I'm chasing it.
thank you so much for sharing, Mr. Anuj. That's such a heartwarming story from a little boy who chased after something that he doesn't even know, from him getting able to get it connected. And all of this has been proven to be where he is today. Thank you so much, Mr. Anuj, for sharing. Next, perhaps we can hear from Miss Rainy. Would you like to share with us what has been the inspiration behind Miss Rainy today? Miss Rainy, I think you are muted. I'm sorry.
Oh, sorry for that.
It's
For
good.
me, all right, okay. For me, the inspiration for me is coming from one book. It's a book of Cosmos by Carl Sagan. Yeah, I do like space. I do travel a lot to look at the dark sky, to look at the stars and learn how the stars evolve and all the space exploration. By the end of the day, when I learn something, I feel something missing. The missing part is how we share our knowledge to the public, share our knowledge to the surrounding us. One day, I discovered a book, and fortunately, when I read at the biography of the author and also how actually that book actually become among 100 books that changed American, it gave me surprise that one book that can change the mind of American. And I go through that book, and it is from Carl Sagan. And I watched Carl Sagan since then, and I learned how I can communicate better in science, in astronomy, in space, and not to look like too nerdy or too, I mean, techy, where we want to get our public interested into space, to STEM, to science, there must be a way, because how the Carl Sagan wrote his book is a storyline that you can't stop reading it. Like a novel. It's not like a normal science book that we have. So that is the part that for me interesting and inspires me a lot, because he opened up a mind of American. He opened mind a lot of minds actually. Because if anybody of us know Carl Sagan, and he has his student right now. Anyone knows who his student? Uh, I will tell you know I will let you know the name after this. Um, the way he portrayed the message that inside his book is, I mean, amazing, and it helped everyone that read his book, even though they are not a science student and not into science space, become interested to space, and it helps NASA at the end of the day to, I mean, with NASA project like Pioneer and Voyager, we know that pale blue dots coming from him, because he has the authority to, I mean, ask NASA to turn around the Voyager and to look at Earth from far Saturn, and we have one dot, I mean, pixel, and they name it as a pale blue dot, and that's how we know we are actually just one dust in the space. So it gives me something that if you want to be a good, I mean, communicators in science, in space, you need to know how to, I mean, communicate with people. Yeah, we have a challenge here, right? So with most of the science, I mean, scientists or those who are into science have challenged to convey the right message to the public. So the public can buy the idea why we need to explore, why we need to learn the space, why we need to send human, why we need to send robots out there. So the communication part is really important. And for me, Carl Sagan has played a big role for me to influence my, I mean, interest in space, and also to understand how to talk, to speech to the public.
Wow, that's a wholesome story to prove the power of role model by having a single person, and he has inspired you so much. Wow, that's amazing, Miss Rainey. Thank you for sharing with us. Perhaps next we can hear from Dr. Mila. Dr. Mila, what has been the inspiration for you?
So I hope you can hear me. Yeah, I
Yes,
have
doctor.
related
Clear.
stories to both of them. And yeah, again, growing up, I used to look at the sky and really wonder what those objects are, how to get to them. But unlike amateur astronomers who, like the vision of it, how it looks, how to photograph it, I also wanted to know how they work. And that set me on that path. And kind of like Rini, I was also very influenced by Carl Sagan. I watched all the Cosmos movies and, even bunked college to attend those movies. And so, uh, so that also again inspired me not just in, following that path, but also the science outreach, how beautifully he could convey the ideas to just about anyone. And so during my path, I did a PhD. And again, I want students to realize that once you finish a PhD, it's wonderful. You have, you have the credentials, but it is tough because, especially in sciences, because you don't know how your experiment is going to pan out, and maybe at the end of 6 years you'll be left with nothing. So you have to work hard, and you have to be a good. You have to keep exploring. You have to keep trying to find the solutions. And I always went for a dare. Like if anybody said you can't do this, then automatically I would set my heart on proving them wrong and doing it. So these are the kind of motivations. And also, I would like to say my father was a scientist also, and he also encouraged me to do all kinds of science, like answer mental math questions all the time, do solve little tinkering problems. If the radio broke, he gave it to me. So through all this kind of things, I developed my interest in learning about everything, trying to solve things. And I would, and then share it with everyone. So that's why I followed this path of astronomy. And also, I like to do science outreach. And I would, I'm a lot older than some of you, but I still learn all the time. I'm attending workshops, I'm conducting workshops, so both roles. And I'd like to add an additional thing that, often, like Rini said, people identify STEM people as nerdy or very one dimensional. And I also do a lot of dancing. So I like to promote the idea that, you don't have to be left or right brained. You can do everything, you can combine things. So that is the idea. Thank you.
It's amazing, Dr. Mila. It's amazing. Wow, you are true epitome of curiosity. And of course, hearing to you, it shows that, oh, it runs in your blood. Wow,
Right.
amazing.
Yeah.
Highly inspiring. Thank you, Dr. Mila.
Thank
Next,
you.
let's move on to our last speaker, Maidili. Maidili, what has
Hello.
been the inspiration? Yeah, we can hear
Yeah.
you,
So
Maidili. Take it away.
okay. So as far as I remember or have memory, I have always been intrigued with the planets, mainly planets and all the stargazing and all. So we when we moved to a new house, my whole family. So the room allotted to the kids, they had a roof wallpaper that was full filled with stars and all the planets. So I was like, I knew their names, but I didn't know how much information I could gather. So what I used to do, I used to wake up every morning. I used to search, and I used to spend hours on it, literally hours, just finding out just for information. I was probably in eighth or seventh, but I still do it. I probably didn't get much, but it was interesting for me. So with that, I started learning more, exploring these all kinds of fields. Then I started doing my own research in undergraduate. So that's
Thank you, Miss Maidili. Thank you for sharing that. It reminds me of my room. Back then, we have these glow in dark stickers, glow in
yeah.
dark stars and everything. My sister and I, we were little kids back then. We are short. So we tend to gather the chairs, tools, and put it so that my parents wouldn't know. And we will try to stick it to the ceiling so that we can see it's like being colorful when we are sleeping. Ha! It
Exactly.
reminds me. Let's see when you talk about yourself. Thank you for the refreshing memories. Okay, now that we have known the inspiration for each and every panelist that we have today, when we are hearing to them, it feels like the girl next door, the boy next door. So, which shows that you and I, we could be like them one day as well. So, now let's move on to the more technical component of the entire panel session today. Perhaps we can get started with Mr. Anuj. Mr. Anuj, I would love to know what has been the scientific discoveries that we can expect from the future deep space exploration missions.
Hmm. Uh, sure. If I'm talk about the like scientific discoveries in the deep space, right? So it first reminds me to gather the very first fundamental question, that the understanding of the origin of the universe, because at present day itself we are not 100% sure that how exactly universe was originated, right? And what was the fundamental, or you can say the core answer that believes that yes, this is the prominent theory which suggests that this is how the universe is originated, right? But still we are not gathering that, because whatever we know till now is the observable universe, right? That means there are still remain, and what is it, we don't know, right? So that's why what I'm saying, whenever we are going for that scientific discovery, this is the first and very most prominent question, right? To understand the origin of the universe. And then after that, for that we are actually establishing so many space-based telescopes, like the recent one, James Webb in the space telescope, and it is gathering the data from the far away galaxy, exoplanet, right? Which even suggesting that okay, what we are is beyond that, right? Because before that we had the Hubble space telescope, and that was at that time was the world, right, which was answer about these fundamental questions. Now we enhance ourselves to put more technology and more advancement for that. We are getting the more interesting and most unknown facts about the universe, right? And then we are talking about the definitely the exoplanet exploration. Whenever we talk about the deep space discoveries, we always look for the planet which is like twin to Earth, right? Which we can where we can expect life, right? If we want to be a multiplanetary species, we want to go there. So, what was that planet, and what could be that planet? Is it habitable or not? Is it just like Earth? Is it have the atmosphere? Is it have the liquid water on the surface or not? Right? So these kind of exoplanet exploration discoveries are very essential for the same, right? And yeah, when we talk about within our solar system, right now I'm not going beyond it. I'm just talking about within our solar system. So within our solar system itself, there are multiple moons and multiple planets that we can reach out to, right? So Mars is obvious, right? We already been there, but not as a human, but as a lander and a probe and our fighter race. But beyond that, we have the Enceladus, Europa, Titan, which are looking for the astrobiology as the most prominent place where we can find the sign of life, right? So to find a life itself a challenge, right? Because whatever we know today, the definition of life is from the perspective of Earth only, right? Maybe if one day we find a life on a different planet, it can change the whole perspective of our definition, right? So that is the very interesting thing. That is the part of the discovery, right? After that, we have the fundamental physics behind our whole universe, right? We don't know anything about the dark matter, the dark energy, and, yeah, and yes, that is the chance and that is the platform to actually test the theory of relativity given by Albert Einstein, right? So this universe and this deep space is actually a platform to do the discoveries, because what we know right now is a tinge of you can say a very tinge of the universe, right? There is so much thing that is unknown. That's why we call the universe as the study of unknown things, to know the unknowns, right? That is the thing. And
Yeah.
then the interstellar exploration we have about like the world of spacecraft, which actually go beyond our solar system and consider which what happened in the universe. We never have ever have like thought about that if any of the spacecraft beyond our orbit, like solar system, right? I was in the space. So that is the problem of physics. That is the problem of where we are depending for the limitation of space and of space, right? That is the thing, right? That is where we are fundamental the asteroids and comets, right? We are studying actually to carry out some of the essential minerals and essential resource which we can utilize for the further explorations, right? And right now the field of science is still you can say the enhancing with the addition of the space weather and the space environment, so that we can actually build a sustainable structure infrastructure for the future astronauts that do some sciences over there. So this is all of my you can say the perspective on these scientific discoveries in the deep space, and I definitely want if you guys can add on my points if there is something, right? So here's my view.
Thank you so much, Mr. Anuj. I love the fact where you started with having encouraging people to have a deep understanding of the matter that we are talking about, the deep space exploration. And also I could see that you mentioned about Hubble, James Webb. That means it shows the transition of the technological advancement. So talking about technological advancement, perhaps we can hear from Dr. Mila. What are the technological advancements are vital for future deep space missions, in your opinion, Doctor?
So, as Mr. Anuj said,
Yeah.
that for every detection or discovery that we make, we act on that to make the next mission more advanced. For example, for exoplanet detection or for search for extraterrestrial, life, we started with missions like Kepler, which had a certain detection ability. Then we went to Chess, which had a higher detection ability, could go out further, could look further. And then finally, we went to JWST, which has very advanced techniques, JWST compared to Hubble as well. So now
Yeah.
the point is that we are trying to look further and further away. Deep space missions, as we are talking about in this conference, are mostly missions outside our solar system, or maybe far enough away to what we've never gone so far. So the problem is distance. The problem, so things like, so if it's distance, and also places we've never gone to before, so these are some of the things that our missions will have to face. Are how do you go that far? So you need an advanced propulsion system, so it can go further distances. Okay, so of course we all talk about space debris and sustainability, and now we have more and more spacecraft and satellites in space. So all of our missions will have to face not only the problem of collision and interference, but also how do they communicate back. So we need better communication systems, deep space communications, and we will be coming to that later too. So yeah, we need advanced ways to communicate back. We need radiation. Some of these missions may need radiation protection. They'll be going a long distance, and space is filled with cosmic radiation, maybe meteors, asteroids that can hit them. So we need better material, things like that. And then also things like the missions themselves have to have uh, things like sustainable life support systems. And as we are even going to send astronauts to space back again, not so deep space, but still. So we need habitats and missions that have sustainable life support systems that can recycle water and air, and can also generate food and recycle waste. Because when you go far enough away, there's no way you can depend on Earth to send you supplies like the International Space Station does. So you need a more self-sufficient system. And exploration, you need better telescopes, better detectors, and all our technology is improving, so we have all these better. Also, uh, if we reach planetary surfaces, then we need better ways to explore them, like rovers, like autonomous things like rovers or robots. And
True.
even the methodology, even in Chandrayaan 3 we use this drilling and laser, pointing a laser and make the plasma come up. So we need better technology that it can explore the planetary surfaces. uh, so these are some of the kind of things: better communication, better propulsion, sustainable life support, uh, fuel. So these are some of the kind of things that even the spacecraft have to be made of better material to protect against radiation and against collisions. So these are some of the things that we are going to be needing to study about more, and all of these aspects are being looked into now.
Thank you, Doctor. I think you have brought up a very good point, saying that deep space exploration is mainly about somewhere that we human may have not been there before. So, talking about these types of deep space exploration, whereby there would be no any human presence over there, and there it comes the rovers and also robotics to support them. So maybe talking about robotics and rovers, I would like to hear from Miss Rainey. What do you think, perhaps the basic advantages and limitations of using robotics and automation when it comes to deep space exploration? Perhaps we can hear this from you before we delve deeper into the robotics and also the rovers itself.
All right. Thank you. It is quite a good question when we say about sending robot to space. Why don't we send human? Why don't you mean just go there and do things that we want. Why we need to have building robots and for everything. So this is important thing that we need to know before we go out. Normally we scout. It happens normally anyway, right? Now for our army, for even for ourselves, we want to go something. When we hesitate, we don't know what in front of us. We will send something. So it happens again and same to this space exploration. So we send robots or rover for the remote operation. So we don't jeopardize ourselves, put ourselves in danger when we don't know yet the situation. So that's how, and that's the reason why we send robots. And for surely, a robot is automated systems where they can perform a task in an environment where human can exist. You don't need to have like oxygen in the way like the rover when we send them to Mars, but we send human, you need oxygen. And we also send our rovers or robot to do kind of experiment, not just to the environment, but also to the instrument itself. Like our Perseverance rover that been sent in few years ago, and recently came out with the data that they are successfully extracting oxygen from the Martian atmosphere with the MOXIE. So it shows that the technology demonstration is successful. So that small MOXIE device in the future can be scaled up for the human exploration to Mars. And one more thing you have to remember, when we want to send human to outer space, you need a lot of money because you need to prepare the man for a training, for the equipment, for the safety and everything. And to send a robot or a rover, it's cost effective. And it's more than human. The cost is lower than that. They don't need to have a food, don't need to have oxygen, just to make sure. They can work based on what the task that we given them. And at the same time, we know we have limitation. Human has limitation. We can't stay 24 hours. We need to sleep. We need to eat. We need to do a lot of stuff. Yeah, we have psychological part as well. But with the
And I
robot,
believe we fall sick as well. Sorry,
yeah,
and I believe that we do fall sick.
yeah, we
Yeah.
do. So the rover, don't have that kind of things. So the mission can be extended. We can see numbers of mission by NASA itself been extended few years ahead from the expected date. Those mission should be, ended. So with the proper management and coding, programming, and a lot of stuff, we can make it the duration of the mission longer and longer and longer. But in human, we have that kind of limitation. And when we do a scientific mission, we need precision, we need repetition, where human always have difficulties on this. By robots, we have the data with us. Now we have machine learning, we have AI. So it can help us to ensure that the task will be precisely done accordingly at the exact time. If you need to do a millimeter, they can do that millimeter or millisecond, yet human can't do that. And that is the advantage of the robots. And yeah, sure, because of the safety, we need to think about ourselves first. So that's the reason why we send our robots, the rover, to outer space. But the limit, that's a good thing when we send rover or a robot to space. But the limitation is still there, where they still need human intervention, the limited of autonomy. They can't think. We need to send them a message. We need to send them a coding, the task for them to do things. So they can't think until we give them a accurate AI, all the variables, the coding and the programming, so that they can think. They can learn by themselves. It takes a long time to reach there yet. And we know, even though they can do a lot of things, but they also need to be maintained. Like what happened to the Martian rovers, like Perseverance, we have like Curiosity, we have numbers of rovers there, right? They can't clean themselves. They have like a Martian dust, so they can't even clean their solar panel. So still, they have a limitation on that. And the robot, not like human, we can adapt easily. I mean, you can think we can adapt based on time and location, but robot can't. What you give them, that's what they are. So if they can't climb a hill because of this, they have a small wheel or the wheel is torn, they can't change it. They can't adapt. They don't know how to do that. So that part of the limitation that, I mean, sometimes make the mission, stop or fail. But it's combination at the end of the day of the human thought and also the development, the advancement of the machine will help us to explore further to the space.
Hmm, very well said. Thank you so much, Miss Rainey. You have proven that you are a true science communicator when you could draw the deep space exploration of robotics and rovers with having like army of people whereby we send them when we don't know the danger. Yep, and that could make me to easily understand, oh, that's the logic behind it, that why we are sending such. And that you're saying a lot more about the rovers and what are the advantages and also limitations. Talking about the advantages, you did mention about astronauts and why they are expensive, and sending them even further that might be even more expensive because it's a responsibility to not to only send them but also to make sure that they come back. It's a responsibility that each and everyone would be holding to as well. So talking about the astronauts, perhaps Miss Maithili, you may enlighten us. What are the key challenges and risks for astronauts on extended deep space missions and how they can be reduced over time? Take it away, Miss Maithili.
Thank you. So, starting with the astronaut mind, I think the main concern would be mental health, as extended deep missions can be extended to years or even a decade if we are actually advanced enough in time. So, I think the mental health of the astronauts is a major concern regarding this, and also the radiation factors that it might include. Uh, cha- the galactic cosmic rays and solar radiation, it may damage their DNA as well. So I think the risk of
Mhm.
cancer is also prominent in astronauts' health now. And another concern that we can take is gravity. We are we are very familiar with the concept of gravity, but there is no gravity. And if I talk about International Space Station, most of the astronauts face microgravity or zero gravity there under. So what happens in microgravity is that they are, due to the lack of gravity, the bones and the muscle and all these things are deteriorating and leading to more health problems in the body itself. So yeah, this is another one, and also the communication delay. If we are having a deep space communication system, but even then it would take a big amount of time to make communication with the Earth station. So yeah, this is also one of the main concerns. Like in that time, astronauts should be able to provide themselves with a proper decision making process in the in the travel as well. So yeah, I think, and also some other concepts that we can take are meteorites, micrometeoroids, and cosmic dust. It may harm the solar panels and spacesuits and the whole spacecraft as well if we are not being careful with our journey. Or so it would need some guidance system as well. The spacecraft would need some guidance system and some shieldings for the spacesuits and the spacecraft as well. So, a spacecraft for deep space communication may have thick walls, like it should have, so that the most of the radiation protection or the cosmic dust and these can be lessened. So, yeah, I think this is all, and then we can have simulators, like if you have heard about AR and VR technologies. Yeah, so AR/VR technologies are also creating a major impact on these simulations that may help the astronauts. Like in astronaut training, you can train them everything about the technology and how to take decisions. even mental health. But the real simulations, if we are taking into consideration, then they are more practicing with the real cases or advanced cases that may arise in front of them, but in a safe environment as well. So yeah, so I think these could be some of the main things that we can do to reduce the astronaut challenges that we have.
Thank you so much, Miss Maithili. Like when you were conversing, I could hear lots of firm stances and also lots of maze, which maybe if I could conclude them, we have lots of knowns and unknowns when we are dealing with deep space exploration. So talking about these knowns and also unknowns, the uncertainties, it just blinks it just beeps into me that how about the extraterrestrial life? Like, do we have them? Do we need to look for them? And those questions like popping in my mind right now. So maybe I can hear from Mr. Anuj first. Like, do you think is it important to search for extraterrestrial life in deep space exploration? And what do you think the strategies that we could consider?
Thank you so much, Uma, for this wonderful questions, because this is the question where our field actually started, because this is our basic motivation whenever we talk about astrobiology. This is our main motivation, that we have to find a life in the universe. That's it. We are microorganism, anything, right? So for that, so to solving this question, so by far we get a one benefit of doubt, right? By solving that question, that where are the aliens, or can we find extraterrestrial life on any other planet, uh, automatically we are solving one more question that is indirectly solved, that is understanding our place in the universe, right? We know we are on the earth, but in the vast universe we don't know exactly where earth is located, where we actually belong. By solving that particular question, that okay, that particular planet have the life, so by that we also understand where we actually in the universe, and how far they reach and how far we reach, right? That is the thing. And then after finding a life on any of the planet, or you can say the extraterrestrial life, either it can be intelligent or either it can be just arrived, right? So it brings us to understand how life was originated and how life is going to evolve, right? Because we know when the life started on earth, it actually started from the blue green algae, right? A very tiny blue green algae. We were all the ancestor of that particular thing only, right? And here you can imagine the life which is that much advanced, that have the materialistic DNA, and that much advanced that they can build their spacecraft, they can live there, they can grow plants and whatever the food consumption that they can. So this is the chain, and this is the one-way path from where exactly you started at the zero, and now you are at that point of time, that you have all sort of things. You have automated generated fuel, and you can extract the fuel from your surrounding itself, right? That is the advancement, you can say the technological advancement, that yes, for searching life in different place will leads to the advancement of human technology as well, right? Right now we are using certain type of technologies and certain type of methods to detect the life, right? So we know either we will pass or either we will fail. If we fail, right, so that is not the demotivation, it is actually giving us the new idea, okay, so we should improve ourselves, and we should come up with a new technology, right? So that is the power of science that we utilize, right? And also this will bring us to find if any sort of planet have life, that means it has to have on its habitable zone, right? So we need now we need to understand what is the habitable zone. Habitable zone is actually an imaginary zone which is around a particular star, right? And if any of the planet is lie in that particular zone, that means that particular planet have the power to sustain liquid water, having the right temperature to sustain a liquid water, as well as we can expect life there, right? It could be a basic life, it could be advanced life, but that is very important. It has to have the right distance from the star, right? And then after that, we'll definitely look for the biosignatures, right? So for that, we are having, and we are actually using a different technologies. For example, let's talk about the Jab Wave Space Telescopes. We have the spectroscopy technique. With that, we are actually looking at the particular exoplanet or the particular planet, and it actually gives us a spectrum which actually defines, okay, these are the certain minerals, these are the certain composition which is present out there, right? Which help us to understand, okay, these are the transition happen, these are the chemical reaction that happen, and these reactions can only be done by if there is a presence of life or either not, right? That is the thing. And then definitely we'll talk about the like Mars exploration. We are sending, like recently we have sent the Perseverance rover, right, on the Mars. And believe me, this particular rover, also known as the astrobiology rover, to find life out there, right? Because it is at that crater, that is Jezero crater, right? It is actually considered as the uh, crater or the lake where the inlet of a river as well as outlet of a river present. That means one side of the crater, the water is coming, and another side, water is going, right? So we can expect a life over there and at some ancient time. That's why we are searching for the stromatolites or some sort of microorganism that is present there, right? That is actually giving us a hope, right? So in definitely, if we talk about the Europa and Enceladus, if we go beyond our asteroid belt, and the missions get more improvised and more dramatic, and you can say like beyond our imagination, the Clipper and the Juice mission, right? Clipper mission is actually dedicated for the Europa to study beneath the subsurface ocean, right? The subsurface ocean, it is the water that we can't expect in our earth itself, right? That much water is present in the Europa, right? Then comes the Titan. Titan is very much known for the hydrocarbons, right? And our life is itself made up of the hydrocarbons and the carbon contained compounds, right? So that particular planet have the liquid oceans of the hydrocarbons. So definitely there could be a life. Maybe it is different from us. Maybe it's different from us, right? But it can be there. So for that, to study that, we are NASA is sending the Dragonfly mission, right? It's a only mission that happens in the human's history. No one have ever tried like something like Dragonfly, but it is going to be there. It is actually flying over the clouds of the Titan and try to take the image and all the sort of sciences, right? And after that, when you think about, let's go beyond our solar system, let's find something, you can say the different planets like the Kepler 22b, like Kepler 62, right? And as well as like different planets, right? So how we are going to actually find it, this is the one fundamental question. Here comes the science. Here comes the science. So we are actually using three different type of techniques to detect the exoplanets, you can say, right? The planets beyond our solar system. That is, the very first is the astrometric detection, right? And then comes the radiometric, or you can say the radial velocity method. Then comes the Doppler shift method. So by these things, we can actually detect that, okay, there is a there are certain planets that is actually revolving around that particular star, right? So after that, we need to fix either it is on the habitable zone or not. If it is in the habitable zone, the liquid water can be sustained on that planet or not, right? These are the criteria that we need to follow in order to find the extraterrestrial life, right? So it just like these are the benchmarks. First, we need to check it. So once we check it, okay, now we can say there is life or not. So these are the benchmarks, right? And also, when we are talking about the extraterrestrial intelligence, that means life which is actually
Oh,
advanced, having the technologies developed, right? So for that, if since we are capable of doing the communication in the radio waves, right? We have the radios, right? We have the optical space-based telescope. So can we consider, might be there are the possibility of these what you can say, the community, or you can say the colonies, using these technologies. They might also be using the radio waves, just like we. They might be using the optical signals, just like we are doing, right? And then comes the laser. So that's why we divided the particular SATI divided. SATI divided the three categories: the optical SATI, the radio SATI, as well as the laser SATI, right? So these are the advancement. Initially, we were using radio SATI. We are sending the different type of signals in the space because our space itself is having so much noise, so much radio noise. It's very difficult to distinguish which part of the radio signal is important, which is not. It's a very tedious method. Then we evolved with the optical SATI. Then we further narrow it down. Let's come to a laser SATI. Then we are sending a particular beam of a laser into this space, and with the hope of the signal will return. Right? It's a game,
Wow.
right? And
Yeah.
and you must have to understand one particular thing, that we are coming up with the very famous, what you can say, the project, that is the breakthrough project, right? And breakthrough project itself a project uh, that we are actually planning to send our very neighbor star, that is Proxima Centauri, right? In our Andromeda galaxy, right? So here we are actually sending the project Starshot. There are multiple small pea-size satellite. Okay, we are sending all these satellites into the direction of Proxima Centauri with the help of condensed laser beam. Here, right now, we are using light as a source of the fuel. First time in history, right? So this is how the technological advances also take place. We definitely
Wow.
think there might be extraterrestrial life out there, but the only thing is we haven't made any sort of contact yet. But with the hope of, because there is one poster that in my wall which is written as, "Our universe is too big to be alone." Right? Isn't it true? Because we don't know how far universe is going. Definitely, it could be there because we haven't reached there. Right? That's why it's saying our
Yeah.
universe is too big to be alone. Right? So
Yeah.
by that,
I think it's
yeah,
more like what Mike Lee said as well, like unknowns and the unknowns, and there has been like so many. It felt like I'm attending a crash course into this extraterrestrial life. Wow, that's amazing, and that's extremely a lot more to know about it, Mr. Anuj. Maybe talking about this extraterrestrial life, perhaps we can hear from Dr. Mila as well. Doctor, do you have anything to add on to what Mr. Anuj has said?
Yeah, I think Mr. Anuj has given a lot of information and
Yeah,
it was
please.
very interesting.
Absolutely.
I'd
Yeah.
like to, I'd just like to address it from a different perspective. And,
Yeah.
the interesting thing about astrobiology and some of these new fields that are coming up is it's interdisciplinary. So, recently, last week, I gave a talk at a biology lab about astrobiology. So basically, it's not just advancement of technology in space and astronomy, but it's also advancement in technology for biologists. Like how are they understanding life, the origin of life, evolution of life, also advancement in technology for geologists because they have to compare other planets such as Mars to Earth or understand about volcanoes. Can there be life close to volcanoes? What kind of elements or composition is in those areas? So, what I want to say is that you have to, astrobiology or search for life is very interdisciplinary, and we have to have advancements in all these sciences and methodology. Coming back to some of the methods that Mr. Which Dr. Anuj talked about. Sorry. Um, so the telescopes, many of the yeah. So coming, some of the telescopes have advanced. Like we went from Kepler to TESS to JWST, and as he made the point, recently there was the exoplanet K1218b, but JWST could actually identify the spectra, and from that it could say that this exoplanet has carbon dioxide and methane in the atmosphere. So this is a new technology because so far Kepler and TESS could not use spectroscopy. So based on that, we have this kind of new technology. For Venus, recently signs of phosphine were found. Phosphine is organic molecules, and so we have missions coming up that will drop through the atmosphere to look for signs of organic molecules. So um, another big mission coming up is you've all heard about JWST. Now let me all tell you that a big mission that is coming up is the Grace Roman telescope that will launch in 2025, and that's going to be the next version of JWST. But one of the things it's going to do, uh, Mr. Anuj said that there are some methods with which we detect exoplanets. Some of them are radial velocity. One of the most common ways is transit. And what does transit mean? If a planet passes in front of the parent star, then there's a dimming of the star. And through the dimming, as it's passing in front, there's a dimming, and you can tell how wide is the sun, what is the orbital period of the planet. You can tell all kinds of things. And that is the technique that many of the missions have been using, transit, because direct imaging is very difficult. Direct imaging means photography. It's very difficult because the stars are so bright compared to these planets around them that it's almost impossible to photograph a planet. But uh, but now the Grace Roman telescope will have an instrument called the coronagraph, with which it will try to block the little sun, which is very bright compared to the planets around it, and then it might be able to see the planets more. So it will go with the direct imaging system. Another, recently, just on the news last week, was the sample return mission from called Osiris Rex, which retrieved samples from asteroid Bennu, and it took 7 years. 7 years back, I was one of the people who, with students, we said all the best to this mission, and now it's back, and it's got actual samples of this asteroid. So such sample return missions will also be very important to actually know what is out there. So yeah, just I just want to add some of these kind of technologies will be developing more and more in the next 10 years based on what we found so far.
Oh, I have lots and lots of questions listening to the amazing speakers that we have today. So to our listeners, if you have any questions, afraid not. We will be having a Q&A session later on whereby you can type your questions into the chat and it will be prompt to the speakers and the panelists. They will be able to answer to all of your questions. So just try to hold them on and bump it on whenever you have the time later on. Okay. So, Doctor, now that you have touched onto Bennu. Yeah, I still remember reading about Bennu when it was launched and talking about missions like Bennu. I believe that it comes with a lengthy process, or rather than a lengthy period of time or the mission that it takes overall. So, perhaps what would be the the data it should be protected, and the data it's very vital for each and every missions that we have. And perhaps we can hear from Miss Maithili, based on your expertise. Do you think, like, how do space agencies deal with space weather and also the cosmic interference in order ensuring the data integrity, especially during the lengthy missions like Bennu?
Yeah, thank you. So, mainly space weather and cosmic interference are definitely the prominent issues regarding the communication of lengthy missions. Now, if we are looking into the data now from ground, from our side, we can only do data collection and repetition of checking and validation. That is what we can do from ground. Whatever data we are getting by using predictive models, we can use different types of modeling techniques and rechecking all the data that we are getting. Now the space agencies also try to protect the software or whatever electronics are on the spacecraft by hard radiation hardened electronics. That's a type of electronics that would protect it from the radiations and the solar rays and solar flares, whatever it's interfacing. Now With these electronics items, components can stand a wide variety of solar storms if we are talking about it. But the next information is if we it is going through some celestial body or an asteroid. Now the communication link or communication path is disrupted. Now in this case, space multiple space agencies come together and they form multiple network. It is sort of like delay relay network. It may be some delay in the communication links, but the spacecraft then provide is provided with multiple communication paths that we can still get the data, but there might be some delay or different path might be involved in the communication process. So that is one thing. And another in spacecraft design. Now the spacecraft journey, we can have communication path related edits, but the spacecraft design is another main aspect in these lengthy missions. Now, spacecraft communication sector or communication component has a term redundancy. Redundancy is a critical aspect of the spacecraft design. These are of these components are often duplicated, and if one fails due to radiation, then the next can do its work. So it's like that. Even if in the presence of an interference, the second component or third copy of the component won't affect the data or the components or the spacecraft mission that or what are its goals. It won't affect that, but it it will have a sort of backup plans for all the electronic devices that are on the spacecraft itself. So it creates a whole environment. It is well depth into the communication section, but with these I think we reduce some delay, like delay and as well as data protection as well. So that's all. I think the NASA is also working on some TDRS networking systems, and also ESA and NASA are working together to continuously get more and more data. And the spacecraft is also tried to be protected from solar radiations. Like if you have heard about solar cycles, it's space weather is like has maximas and minimas. In the whole 11 cycles or 25-year cycle, it's there. So in that duration also, space missions has to be set a limited specific time so that it won't be affected that much. In low solar activity, we have to send them missions as well. So there is plenty of research on when to send, how to design, and how we are going to create multiple paths. So it's a whole another area, I think.
Thank you so much, Ms. Natalie, for the full picture on how important the data is and how do they work. And I love the fact that you mentioned where the space agencies they do come together and they do help each other on any shortages or any shortfalls that they face from
Yeah.
one end to another end. Yeah, thank you. So talking about space agencies, perhaps I'm wondering how would the situation be when it comes to the private space companies, especially in today's era. We have blooming space companies, the private ones. Perhaps, Mr. Anuj, would you like to comment on how do the private space companies they influence the future of the deep space exploration?
Yeah, sure. Definitely, Uma. If you consider a private space company right now, they are coming up with a so advanced technologies and so innovative ideas that you can consider, right? So if we like divide it into segregate into a different categories, you can actually understand these private space agency is also able to increase the competition. Right? Try to understand they increase the competition. How exactly they so? Because they always work on the innovation and the cost reduction technology, right? They just like a government agency, they don't want to put so much money on it, right, on a project. They want to reduce the cost so that as well as they can also working on the reusability techniques. You can use it a multiple time so that it cut the cost, right? So that is the very first thing, that they definitely increase the competition, so that to compete that, government will also try to come up with the same sort of solutions, right? So that is the thing. Then comes the commercialization of space is very important right now, which is actually happening, right? In India, definitely it's happened, the commercialization of the space, so that it actually allow the private industries, right, to do and do some activities working to make the space accessible to all, right? For example, right now the private companies promoting the space tourism, definitely it will help the economy, the very first thing, right? And then comes the space tourism also allow everyone to go into the space and see the uh, earth, or you can say the universe beyond the limitation, and like just standing over here on the earth, right? That is the one thing. Then comes, then slowly we are shifting towards the mining in this space, that means the asteroid mining, that is also the one of the idea, right? So with that, private institutions and all these private companies also focusing on that, because everybody wants to make economy out of the space, right? And how you make it? When you go there, when you explore it, when you mine it, and then you sell it, right? That is the work. Then at the end, the satellite development business right now is very good. There are multiple space private space agencies that are actually creating the space satellites in very cost effective, you can say the amount, very cost effective amount. For example, SpaceX, definitely they are making the satellite. Even in India, if I say the Pixel is the one of the private company in India which is actually making the hyperspectral, the world highest resolution hyperspectral imagery satellite into the space, and a very low cost, right? They are also making a constellation out of uh, over our earth to get the highest, you can say, the data that you can receive from our earth itself. Similarly, if the private industry take part for the different planetary programs, for example, only NASA and ISRO and other planetary, what you can say, the space agencies, government space agencies are making the orbiter and making the lander, making the rovers and send it to the different planetary bodies. And think about it, the participation of private industry will again give you the very less amount of cost, and they can able to send the same type of technology into their orbit as well as on the surface, right? So that definitely these collaborations are very important. That's why we say the collaboration with the space agencies are very important, and that's what SpaceX and NASA is doing. They are doing the work together, and to reduce the budget. And because ultimately once you reduce the budget, or you can say the cost cutting, you can utilize that amount into a different type of technological development for the same thing, right? Same thing is happening on India as well. As we send the Chandrayaan 3, right, our space program also collaborated with a different type of private companies for the same, right, for this development, right? And then definitely, as I already called, the low, it lower the cost with the help of reusability, right? That is the very prominent thing. And with that, what actually benefits the STEAM field is really get benefited, because private and government agencies right now promoting science and education for all these sort of students to come up with the idea, right? And private universities and the private companies are also helping them for the funding for the research proposals and for the research fundings to come up with the idea which can definitely help the global economy as well as the particular state economy. That is the thing, right? So risk tolerance will definitely the major part over here. What do I mean by risk tolerance? Like if you consider, uh, if you say a government have to send a particular project into this space, right? So definitely there will be a risk factor. So government won't allow any sort of risk factor onto it, because it definitely uh, push back them, right? Whereas private industry, they are risk tolerant. If this project fail, doesn't matter. We'll put more money onto it, but ultimately we are going to succeed it, right? For example, SpaceX, right? They made 9 failure missions. By the 10th time, they are able to make the successful, right? So this is how the thing is. They have the risk tolerance. Okay, if it is going harder, let's do it. That is the thing. So that's why what I'm saying, the private industrializations into this business is very important, because ultimately they work at the end, they will work for the inspiration for the students and for the public interest, right? So that's how I'll call some of it. So if anybody wants to add something on it, definitely you can say. And also, like, they are also working on the one major part. I like actually missing it. That is, they are also working on the long-term sustainability, right? So
Yep.
the same mission can be done by multiple times. That means you are actually saving a lot of things, not just a money, but also for the nature, right? You are not utilizing that resource, like just extracting resource from that particular place. You are utilizing the same resource again and again, right? That means it is not harming the environment. That is also the thing. So long-term sustainability is also important.
I
Yeah.
hear this as a power of disruption,
Hmm.
where it forces the entire community or the colony to move towards something that one has done. Uh, the perfect example that you have given on the reusable spacecrafts, where when one could do it, then it forces the others to follow suit as well. And where it works much on the fundings and also brings down the entire cost, trying to bring it down lower and lower and lower to make it more affordable to many as well. Thank you so much, Mr. Anuj. So you have spoken and you have mentioned how crucial it is, and also lots of national collaboration between the space agency within the country and also the private agencies. So perhaps we can expand it and look it further into the international collaborations as well. So maybe to talk about this, perhaps we can hear from Dr. Mila. Dr. Mila, if you could say a few words on how crucial is this international collaboration when it comes to deep space communication, and do you like can you provide us like few successful examples that we could view it?
Yeah, I mean, as we have these deep space missions or missions that are more advanced, then it's going to be very important to share resources, ensure, most importantly, ensure continuous contact with the spacecraft for communication and extend the mission capabilities. So for this, countries will have to collaborate, and and they are collaborating. So let me talk to you about the deep space network that NASA has. And the missions, as they get further away, the communications get more and more difficult. Uh, there are many challenges, as we've already talked about. And one of the challenges is how can you stay in continuous communication? So NASA's Deep Space Network has three antennas or three locations that are 120 degrees away from each other. And so spacecraft can be in direct contact with one or the other of them. So ESA also has this kind of network. So this enables missions to use the Deep Space Network or ESA's network, and even India has a network of antennas to stay communicated. And even Chandrayaan 3 used these facilities of Deep Space Network when it was launching. So this is one thing I want to talk about. And similarly, for things like Voyager missions that have gone very far there at the edge of the solar system, definitely they have used these tracking and communications from all these deep space networks. So I'd also like to talk about an upcoming mission, the NISAR, uh, which is a joint mission between NASA and ISRO, which will use advanced radar imaging to look at land surface changes. Which, as we know, land surface is very important right now. So this is a great example of international collaboration where this is a two-band radar imaging, and NASA will provide one of the bands, which is L band, and they will also provide the subsystem and the GPS, whereas ISRO will provide the launch services, the S band radar. So it's a communication where by which you were able to expand the capability of one single mission using your joint systems. So through things like this, you know we can utilize help each other utilize resources that are available and use the communications. And definitely in terms of space policy, there has to be international cooperation anyway, and that is a strong forum of discussion that is going on right now.
Thank you for the real life examples that you have given, Doctor. And listening to you is just it brings back the curiosity in me to what Rainy has said just now. Miss Rainy has talked about the limitations and also the advantages of it, advantages of autonomous rovers and also robots. So maybe Miss Rainy, perhaps we can use this time for you to add on how do these autonomous rovers and also drones, if we can, assist in exploring the celestial body and establishing the communication links that we have discussed so far. Oh, Miss Rainey, you are muted.
All right. Okay.
Okay, yeah,
Sorry for that.
yeah.
All right. Okay. So we heard a lot about how we can, improve our communication in space. We know in space is huge. The data transfer take a longer time. Even to go to Pluto, it takes more than 4 hours for the data to transfer, transmit, and receive. It takes a longer time if you go further. So we've shared a lot how to improve the data, to secure the data. But looking at the robotics mission, the drone, and also the current deep space network system that used by the current space exploration, we can see that all the data, that been gathered is multiple, shared by one single instrument, like a rover. That like what we have right now, we have Perseverance and also the helicopter, the drone, right? The Mars. So the data have been shared. It's not just with the satellite, the Martian orbiter, the MRO, but it's also been shared through the instrument that have in the what we call the Perseverance and also with the drones. The Mars helicopter capture all the photos, scouting, and give the high resolution data, and then been transferred to the MRO, the Mars recognition orbiters, and it transmitted to the Earth. So we've heard it just now how what the challenge through the bandwidth that we have. But currently, what we are looking at, NASA are trying to build the optical, communication. Soon we will have like a laser communication, but it's still a challenge because you need to pinpoint directly where the location of the rover or the mission. Still, the limitation is because of the distance. The relay is there, the redundancy is there, and the challenges like a solar storm, it's always be there. It's how we multiple the situation. It's same like we experienced the first exploration from moon, Earth to the moon, when we have our astronaut go to the moon and then come back. When they are entering our atmosphere, they'll be covered by the plasma, right? And that time they won't have any communication. It's a totally darkness. But now we don't have that because we have a relay satellite. So the global mission with the global collaboration will help. It's still we need to understand science is fixed. How fast is the message can be transferred? It will be on that fast. You can't make it faster than light, right? Though it takes about 4 years or 4 months or 4 hours. It will be 4 hours. You can't make that faster. It's already there. It's stated in the science. It's how we make sure that the data are not lost or redundancy to make sure that all the data are safe, because maybe in the way all the data are being, lost or disrupted by the I mean solar radiation or storm. That's the thing. So for the rover, for the drone, they can collect all the data with all the latest equipment we have. We can collect the high definition data. We can hear the sound on Mars. But still, at the end of the day, how we amplify the data to make the data, more complex. Previously, we use a simple data, so we can only hear or we can only see the black and the white, view of human landing on the moon. Now we have HD. Now we have higher resolution. Yeah, it takes time because the radio wave that we send takes time, and also not much data can be carried. The bandwidth not like as our light. So now using the optical laser communication that been tried to the moon, we might see in the future like what we have right now with the fiber optic. Sending data through the light soon will be materialized, and then we can have the real data. But the most important part is it's not just about data communicating, but also, um, to send to receive the data in a way that everybody here can receive it as what we want. Let's take an example, because previously we have multiple mission to space. When China sent their mission to Mars, some country, they have like a closed, what you call policies, right? You can't simply get the data from them. But then all around the world, no, they reach Mars. How that happened? Because the data is still there. All the astronomers, all the radio amateur still can hear the probe land on Mars. This is wrong that time. Though we're still waiting for the announcement from the China, but then everybody cannot deny the land on Mars. So it is the same thing, because we need to make sure that nobody can claim something that untruth. And if something happened, all the global community can help. That's important for us to understand that the communication part is really important. And though we have like a lot of data will coming in, how we amplify the data, how to make sure the data is, safe from the situation in space, are now being, a big concern, because as what we know just now, our solar cycle are now increasing, and will be a lot of solar storm, and that's what we are afraid of. So yeah, that's going to be a big challenge. Even on Earth, we have numbers of SpaceX satellites, right? The Starlink suddenly black out and enter again to the atmosphere due to the solar storm. So imagine if the solar storm become more active, and then we are sending out something to space and we can't connect with them. So hopefully, with the AI, we can predict, I mean, better ways how we can communicate, and the system or the technology there can be uh, can adapt. Mission adapt, and also the mission will be learn how to communicate with us due to the condition. A lot of things need to be done.
I totally agree with you, Miss Rennie. Like talking about rovers and drones, robots, and also Mr. Anuj repetitively mentioned about Mars and the missions over there. And talking about all of them, there is I remember reading an article saying that there have already been 15,000 pounds of trash on Mars already been there without even humans presence over there. So perhaps I would like to know about the space debris and also the space traffic management, which will affect the deep space communication as well. And how can the innovation address this? Perhaps in the interest of time, maybe we can hear it quickly from Dr. Mila.
Yeah. Uh, so yeah, talking about we've just been talking about space debris. That's a big challenge. So there
Yeah,
is so much now, especially in the low earth orbit. And the problem is it's not just defunct satellites that have completed their lifetime, but even parts of satellites that at in that location at that speed, even parts of satellite or can create a lot of damage. In fact, a small fragment of paint hit the International Space Station and created a crack in its glass cupola. So yeah, so
yeah,
the
yeah.
risks are risk of collision. Uh, then you're sharing the bandwidth, so there is a signal interference that can happen. Then you know uh, even the satellites in lower, but many of these missions, deep space missions, will not just communicate with ground antenna, but also with receiver stations that are low Earth orbit satellites. So even those will not be able to receive your communications. So we have to protect against collisions. We have to protect the communications, the bandwidth interference, bandwidth and signal interference. So how some of the ways this is being done is of course we all know this because it's a big problem, satellite space debris. So there are better
Yeah.
methods of satellite space debris tracking and monitoring have to be figured out, and there have to be advanced communication techniques, technology. As Rini said, one of the things that is being looked at is not just radio wave communication, but laser optics communication, because that will be able to send a lot more data in a short time, and that's because the beam won't expand out so much. Okay, so that's advanced communication. Then satellites have to have an autonomous systems of to prevent collision, so that it's not just being controlled, but they can do it. Then spectrum management has to be done. Space traffic management of decommissioning satellites or raising some of them to higher satellites. So regulations have to come into place. So yeah,
All of
space debris can create a lot of problems, but some of these technologies and solutions are being looked at now.
Yeah, thank you, Doctor. So, talking about this, you mentioned about data and how the data are being disrupted with the knowing that our low Earth orbit has been overcrowded with the space debris as well. First, we can hear from Miss Maithili. Like, what's your take on this, Miss Maithili? Like data,
Yeah,
space debris, traffic management. How do you think that it affects?
thank you for passing it on to me. So, I think that mainly innovations are most important in this field, or I can say a space cleaning, like whatever low Earth orbits or higher orbits are there, they have to be cleaned out. In the recent article that I was reading, ESA have been doing or pooling multiple ideas on how we can clean out all these things. Like they range different types of spacecraft or satellites. They can go up in the space and they act as a harpoon. Like they throw the net in that direction. They whichever they see the space junk or the particle or whatever may be the remains of a satellite, they capture it and then they bring back to the earth. So that is
Yeah, but
what
they
they
do
are
have the
working on.
challenges.
Yeah,
Yeah, but they do
they do
have
have
when it comes about these harpoon techniques, but they do have their own
yeah.
challenges in terms of like the speed that they are traveling. Right, Miss Maithili, what do you think about that?
Yeah, actually, the speed that they are traveling is a major concern in the cleaning of it. But the thing is, they have to be have a very strong navigation system. Like they have to have like eyes all around the body itself. Like whatever their pictures are being captured, then they have to be processed nicely, and the direction in which it is throwing that. Similarly, they
Yeah,
have to take a repulsive force like a puff of air, to maintain its steady location for the capturing and the returning of the space junk along with the satellite, that whatever we are sending.
Very well said, Miss Maithili. Very well said. Perhaps we can have a one last question in order to conclude the everything that we have spoken today. So, with the current deep space communication challenges, how do you think that it will evolve in the next decade? We're talking about all this deep space communication. So, perhaps to answer this, I would like to invite Miss Rennie. In your opinion, and what do you think that they will evolve in next decade, because it's evolving rapidly even as we are talking right now. It's evolving, so in a decade more to come, what do you think in your opinion?
All right. So in my opinion, it obviously is to go to the optical, I mean, communication, where the data can be transmitted more than the radio wave. And the challenge is only how to make sure everything is lined to make sure that we receive the right laser or the light, and how much energy we need to have to transmit the data. This was one thing, right? So in the future, what we are trying to do now is to make sure that we have numbers of multiple or redundancy of communication. We need to have light communication. We need to have radio wave communication. Everything is important because in space you need to have redundancy for everything. One connection off, still will have another connection. So it only way how we have the technology, who get it first and how we can use it accordingly. And yep, again it goes back to the security because the data is something that people take it as new oil now. Yeah, you're muted.
Thank you. It has been a trailblazing session that we have had. Wow, with lots and lots of knowledge that we have spread across. And in order to conclude the entire thing, maybe we can hear one word from each and every speaker that we have today. One word or one sentence on what advice would you give to those who are interested in the career of deep space communication. In one sentence, Dr. Miller.
Yeah, STEM, including learning about science, but also engineering, learning robotics, coding, and following up on news of such upcoming trends and space missions.
Thank you, Doctor. Thank you. Miss Maithili, one sentence.
Yeah.
What would you say
So
to the future
uh,
generation?
I would suggest, like, after you are done with developing skills, never doubt yourself to apply at different locations all around the world. Whatever you can find, just apply it with full heart. You should go ahead and try it out.
Thank you, Miss Maithili. Mr. Anuj, one sentence. What
Uh, sure,
would
I
you
would
tell?
definitely recommend students who are actually looking for the future or the career in this space. So, build a strong education foundation, gain some technical skill, as well as I would definitely recommend you to enhance your problem solving skill. At the same time, by the end, that you can join some relevant internship or the research training program so that you can make your career out of it, right? That is very important. And be patient and be resilient. You will definitely achieve your goals.
Thank you so much, Mr. Anuj. And the last but not least, Miss Reni, one sentence. What would that be? Your golden words. Oh, Miss Reni, you are muted.
Again, all right. Okay, sorry for that. All right. Okay. Be courageous. For me, it's be courageous. Only two words is enough to tell everything. You need to have the courage to do what you want. If you don't have the resources, go and find it. I mean, we have everything is around us. We have internet right now. We have all the support. So what the thing that you need to have is your own courage. So go out there. The world is for everybody here. We are talking about space. We are not longer talking about our small room. You can be anywhere. Just be a courage to leave your room to go out, because we have like a sentence like to go out. To leave Earth, you must have a courage to leave your cradle, right? You mean to go outside and explore new things. Be courageous. That is the thing that I think the most important part. Even though if you have anything with you, but you don't have that one things, the courage to go out, you won't go anyway.
I love the energy. I completely love the entire energy of the session that we have had. And not knowing 1.5 hours just passed in a blink of second, just like that. Talking to all of us today. Thank you so much. It has been a truly a whole awesome event. Thank you. Thank you. And I would love to pass it to our host for the Q&A session.
That's that conversation was both insightful and enlightening. I am confident that our audience learned important lessons from the session. We hope now open to any questions from our audience. Please drop in your doubts in the chat box.
Anyone, just be brave, like our Miss Rainey said. Be brave. Yeah, we have got one from Prashant Gupta. Can you discuss the pros and cons of leveraging robotics and automation? Yeah, can we have some answers? Perhaps Miss Maitli, would you like to go with it?
Uh, sure. Uh, Pros and cons, I would say, uh, while we are having robotics and automation as a prominent field as compared to cost efficiency, as Renee said, but it also has some limitation as to cosmic dust, or what we can say, um, dust that is connected on the Mars rovers, uh, due to which they shut down after a while. So I think the automation or robotics has some certain limits of maybe around 3 to 5 years. Like, if run they will run out eventually. But the thing is, if we are having astronauts or human life, then they would have a double or triple the cost. So one side we are taking cost efficiency, and the another we are taking some lower life expectancy of the robotics and automation section.
Thank you so much, Miss Maitli. Thank you, Prashant. Yep, we have next question from Shivan Krach. In your opinion, which key technological advancements are paramount? Perhaps anyone, any of these speakers, would you love to answer this question? For Shivan Krach.
Yeah, I can go ahead. I
Yes.
addressed
Thank you, Doctor.
that. Thank you. I addressed it a bit, but I'll just bring up a few key points. Yeah. So because we're going to be going further out, and because so we need uh, definitely we need better communication systems. And better propulsion, so we can go out further. Technology of observing, such as telescopes, spectroscopy, and automation, and AI will play a big part, because such satellites and missions now will have to navigate themselves and make last minute critical decisions themselves. So some of these kind of technology will really need to be worked on.
Yeah.
Thank you so much, Doctor. Shivank, hope it answers your question. Can we have a next one? Next question? Yeah, we have a next question from Aditi. How do space agencies manage the challenges posed by space weather or cosmic interference? And I believe this question has been addressed. Perhaps we can skip this question. Would that be okay? This question has been addressed into the session that we have had. Before the next question? Dear host, perhaps we can move to the next question because this question has been addressed into the. Oh, okay, there has been an end of Q&A session. Okay,
So, with that, we come to
thank you
an
so
end
much.
with our session. I hope everyone doubts are cleared. I would like to thank all our panelists for enlightening us with the valuable experience and knowledge. With that being said, we have come to an end of the panel discussion. I would now like to extend our gratitude and appreciation to all our panelists with a small token of gratitude. Starting with of our moderator, T.S. Uma Shangri ma'am. Thank you for joining us today, ma'am. Here is our small token of gratitude.
Thank you. Thank you for having me. Thank you. And yep, if I may ask Sankit, we will be having this recording online, right?
Yes, ma'am. You can view it on our
Okay.
IEEE SHS channel.
Okay. Just to
Yes.
highlight to Aditi, Miss Maidili has answered your question within panel session, and she has mentioned on how do we deal with the space weather and also cosmic interference to ensure the data integrity. So perhaps you can find in the recording. Thank you.
Next, we have Dr. Mitra. Thank you for joining us today, ma'am. Here is a token of gratitude from all of us.
Thank you for inviting me, and thank you for
Next, we have
very
Dr.
well
Mitra.
organized.
Thank you for joining us today, ma'am. Here is small gratitude, a token of gratitude.
Next, we have Mr. Anuj Soni. Thank you, sir, for joining us today. Here is
Thank you
our
for
small gratitude. So now, next we have Miss
Next, we
Maitri
have
Deshpande.
Mr. Arjun.
Uh, Hello, Kunal. Your voice is breaking. So next we have Miss Maitri Deshpande. Thank you for joining us today, ma'am. Here is a small token of gratitude.
Thank you for having me. It was a great session.
Yeah. We also enjoyed the session. We thank all our panelists once again for joining us and pouring out your valuable insights with our audience. Thank you.
Thank you.
Thank you so much, Prof. Thank you. Thank
Yeah.
you.
Thank you.
Thank you.
It's time for you to test your understanding and earn some more points to climb up to leaderboard. The link for quiz is given in the chat box. We would like to express our gratitude to our sponsors for their support, starting with HP, our technical sponsor. HP is an American multinational information technology company headquarters in Palo Alto, California, that develops personal computers, printers, and related supplies, as well as 3D printing solutions. Next, our streaming partner is StreamYard. On StreamYard platform, you may broadcast over social media directly from your browser. Before choosing the premium plans to gain access to more features, it provides a free option that you may test out. Our social media partner, Get My Fest, which provides all the publicity for our event and reaches a large crowd. With that, we draw the curtains on what has been an extraordinary session. We thank all the participants for joining us today, and we hope that this panel discussion has provided with valuable insights into the world of future of deep communication. Thank you for being a part of Epsilon 2023. We would really value your feedback. Your suggestion will mold us to make more interesting and quality content in future. With our MTTS track, we come to an end to the Deep Space Communication Conclave domain of the third session of Epsilon 2023, which has been one of the most remarkable thus far. We would like to thank all the participants present here for attending the session, and we hope that everyone had a glimpse into the domain of future of deep space communication. Thank you, everyone.